Welcome to this video about linear regression. Today, we're diving into one of the most powerful and widely used techniques in predictive analytics, linear regression. Whether you're a beginner or just looking to refresh your understanding, this video will help you grasp the core concepts, see real-world applications, and learn how to implement linear regression in practice. Let's break it down together and unlock the power of data prediction. What is linear regression? It's a method used in predictive modeling to forecast numerical values. Essentially, it helps us understand and predict relationships between variables by fitting a straight line through the data. There are two main types of linear regression: simple and multiple. Simple linear regression uses just one predictor variable, for example, predicting someone's weight using only their height. Multiple linear regression, on the other hand, uses several predictors. That could mean predicting weight based on height, age, and daily calorie intake all at once. In both cases, the goal is the same: to find patterns in the data and make better predictions. Imagine you're a tailor. Every time a customer walks in, you measure their height and note the pant length they need. After doing this for a while, you start to notice a pattern. Taller people usually need longer pants, so you begin recording this information and drawing a line through the data to visualize that relationship. That line represents the pattern, a straight line relationship between height and pant length. This is the essence of linear regression. Now, when a new customer walks in, you can predict their pant length just by knowing their height. You don't even need to measure first. This simple idea, predicting one value based on another, is what makes linear regression so powerful in many fields, from tailoring to finance to science. It's a simple way to predict one value based on another, like using height to guess pant length. In simple linear regression, we look at one input and one output. The equation is y equals mx plus b, where y is the prediction, x is the input, m is the slope, and b is the intercept. If we want to use more inputs, we use multiple linear regression. That equation adds more terms, one for each input, each with its own weight. Linear regression finds a line through your data and uses it to forecast new results. It's fast, powerful, and widely used, from tailoring to tech. Imagine you run a pizza shop. The base pizza costs $5 and each topping adds $2. So if a customer picks toppings, the total price is calculated like this: price equals 2 times the number of toppings plus 5. This is a perfect example of a linear relationship. The number of toppings is the input and the total price is the output. Simple, straight line math. So how does linear regression actually learn? It starts with a loss function. In this case, we use something called mean squared error, or MSE. This measures how far off our predictions are by averaging the squared differences between predicted and actual values. To minimize that error, we use optimization methods. One approach is gradient descent, which adjusts the model step by step to reduce the error. Another way is the normal equation, which gives us a direct formula to find the best fit. That's how linear regression learns, by minimizing error and finding the best line through the data. Now let's look at how we actually train a machine learning model. First, we prepare the data. That means loading your data set and carefully cleaning it to remove any errors or noise. Next, we split the data into training and testing sets. This helps us evaluate how well the model generalizes. Then comes training. Libraries like scikit-learn make this step quick and efficient. Finally, we evaluate performance using metrics like R-squared and mean squared error to see how accurate the model really is. Let's take a quick look at how to visualize and interpret your model results. The line of best fit shows the overall trend your model predicts, while residual plots help you spot any errors or patterns it might be missing. To make sense of your results, check which features have the biggest impact on predictions. Finally, evaluate how well the model fits the data to judge its overall performance. Before trusting your model results, it's important to keep a few limitations in mind. First, most models assume a linear relationship between variables, so they may not perform well on nonlinear data. Second, they can be sensitive to outliers. Just a few extreme values might distort your results. And finally, many models expect predictor variables to be independent. If they're not, your insights could be misleading. Linear regression isn't just theory, it's used every day in real life. In finance, it helps predict stock prices and sales trends. In real estate, it's used to estimate property values with greater accuracy. And in healthcare, it can predict risks or patient outcomes, supporting better decisions. Across industries, linear regression remains a powerful tool for turning data into action. Let's quickly recap everything we've covered about linear regression. We began with a simple introduction. Linear regression is a predictive modeling technique used for continuous outcomes. Then we learned what linear regression really is. It models the relationship between input, or X, and output, or Y, using a straight line. We saw real-world examples like tailoring measurements, pizza pricing, and even housing markets. Next came the core equation, y equals mx plus b, where m is the slope and b is the intercept. We explored the loss function, mean squared error, or RMSE, which helps us measure how far off our predictions are. We walked through the training steps, fitting the best line by minimizing loss using gradient descent. We visualize this as a line of best fit laid over data points to make trends easier to spot. But linear regression does have limitations. It only works well for linear patterns and is quite sensitive to outliers. Finally, we looked at applications. From forecasting and finance to marketing and healthcare, linear regression is used everywhere. That's it for linear regression. Make sure to like, share, and subscribe to our channel, CTO-X. Thanks for watching.